Morning students, I am Sangeeta, lecturer in chemistry, branch general section, Institute SSGPT Jahirabad, semester 1, subject general engineering chemistry, subject code SC104, major topic electrochemistry, duration 30 minutes. Our topic is electrolysis of fused NaCl or molten NaCl, teaching aids, PPT, animations, diagrams, wherever. Let us recollect what we have discussed in last class. So what we have discussed in last class, we discussed differences between electronic and electrolytic conductors, Arrhenius theory of electrolytic dissociation, definition of electrolysis, electrolytic cell. So once again we will revise this topic. So what are the differences between electronic and electrolytic conductors? So first, so they conduct electricity without decomposition. These conduct electricity with decomposition. Here conduction is due to flow of free electrons. Here conduction is due to flow of free ions. Here transfer of matter does not takes place. Here transfer of matter takes place. Here electrons flow from negative to positive pole. So here ions moves towards the oppositely charged electrodes. That is, positive ion move to the negative electrode and negative ion move to the positive electrode. So here as temperature increases, conductivity decreases due to vibration of atoms. Whereas temperature increases, conductivity increases due to increase in the mobility of ions. So example for electronic conductors, all metals. Example for electrolytic conductors, aqueous solutions of acids, bases and salts. So these are the differences between electronic and electrolytic conductors. Next come to the Arrhenius theory of electrolytic dissociation. So this theory was proposed by the scientist Arrhenius to explain the nature of electrolyte in aqueous solution on the basis of dissociation. That's why this theory is called Arrhenius theory of electrolytic dissociation. So according to this theory, when an electrolyte is dissolved in water, it undergoes dissociation and forms charged particles called as ions. That process is called as ionization or dissociation. For example, NaCl dissolved in water, it splits into Na plus and Cl minus. So positively charged particles are called cations, negatively charged particles are called anions. Okay, this process is called as ionization. The charge present on the cation is always equal to the charge present on the anion. The properties of the solutions are the properties of ions. So when you pass electricity onto the electrolyte, the ions moves to the oppositely charged electrodes. That is, cation will go to the cathode and anion will go to the anode. Okay. So there we have given the equation AB gives rise to A plus B minus. Okay. So that is A plus will go to anion will go to anode and cation will go to cathode. And there is dynamic equilibrium exists between these undissociated molecule and dissociated ions. Okay. So undissociated molecule and this dissociated ions. So conductivity of electrolyte depends upon number of ions. If number of ions are more, conductivity will be more. If number of ions are less, conductivity will be less. And whatever the fraction of molecules undergoing dissociation is called as degree of dissociation. So degree of dissociation is given by formula number of molecules dissociated into ions by total number of molecules taken. So this degree of dissociation increases with dilution in case of weak electrolytes. And this rate of ionization depends upon what? Nature of solute, nature of solvent, and temperature. And next, what is electrolysis? This process of decomposition of electrolyte by passing electricity through molten state or fused state or in aqueous solution is called electrolysis. And this is carried out in electrolytic cell. It consists of electrodes, electrolyte, and battery. So during electrolysis, what is happening? Electrical energy is converting into chemical energy. So if you see the construction of electrolytic cell, so it consists of a cell containing a solution, and here two platinum rods are dipped in the solution, and two platinum rods are connected to the two poles of the battery. So here our source for current is battery. So battery is having two poles, positive and negative pole. So one rod is connected to the positive pole of the battery through a copper wire, and another rod is connected to the negative pole of the battery. So whichever the rod is connected to the positive pole of the battery, that is anode. Whichever is connected to the negative pole of the battery, that is called a cathode. So this is the construction of electrolyte. So on this, when you pass electricity, when you connect like this, electricity will be passed into the solution through these electrodes. So already in solution, they are in ion form. So whatever the ions present in the solution, they will move to the respective electrodes. Cation will go to the cathode, anion will go to the anode. So after going to the respective electrodes, they undergo chemical reactions. So what chemical reaction takes place at anode? Always at anode, oxidation will takes place. Always at cathode, reduction will takes place. So what is meant by oxidation? Losing of electrons. What is meant by reduction? Gaining of electrons. Okay, so here at cathode, so what ions are going? Metal ions are going. So metal will be deposited on the cathode. So this is about construction and working of galvanic cell, and these are the reactions taking place at cathode and anode. Okay, so these we are discussed in the last class. So then come to the objectives. On completion of this period, you would able to understand. So today's our topic is this one, electrolysis of fused NaCl. So you have to understand this topic after finishing the topic, that is electrolysis of molten or fused NaCl. So we are doing the electrolysis of this fused or molten NaCl. So we'll see the electrolysis of fused or molten NaCl. So to do electrolysis, what you need? You need electrolytic cell. So first of all, so if you want to do electrolysis of any substance or any solution, so here our electrolyte is molten or fused, both meaning same. So here our electrolyte is molten NaCl. So you have to take the cell. In that cell you have to take the molten NaCl. In that molten NaCl you have to dip the two platinum rods, and these two platinum rods are connected to the two poles of the battery. So the connected to the positive pole, this is the positive pole. So connected to the positive pole of the battery, this is anode here, and this one is connected to the negative pole of the battery, this is the cathode here. So here inert electrodes, that means what is the meaning of the inert electrodes? They should not participate in the reaction. Okay, so like this you have to construct the cell. So we are taking one cell. In that we are taking the molten NaCl as electrolyte. In that we are dipping the two platinum rods, and these two are connected to the positive pole of the battery. One is connected to the positive pole of the battery called, this is anode, and this is the cathode. Okay, so then we go here. When electricity is passed through molten NaCl, the ions already present in the electrolyte moves towards electrodes. So when you pass electricity onto the electrolytic solution, whatever the ions already present in the solution, what they will do? They will move towards electrodes, that is oppositely charged electrodes, moves towards electrodes. So the cation will go to the cathode and anion will go to the anode. So these are the dissociation. So NaCl is split as Na plus Cl minus. So here Na plus is the cation, Cl minus is the anion. So this Na plus will go to the cathode and this Cl minus will go to the anode. Okay. So these are the cations and anions in the molten NaCl. This Na plus will go to the cathode and the Cl minus will go to the anode. So after going to their respective electrodes, they will undergo chemical reactions. Okay, so what are the chemical reactions taking place here? See, the Na plus ions at cathode gains electrons from cathode to form sodium. This process is called reduction or electronation. So after going to the cathode, so what they will do? So Na plus means it is short of electrons. When it is short of electrons, what it will do? They will take the electrons. When they will take the electrons, what they will form? They will convert into sodium metal. So that process is called as reduction or electronation because it is taking electrons, no? So it is electronation. Similarly, Cl minus ions are going to where? They are going to the anode. Cl minus, so as it is rich of electrons, this minus indicates already it is having electrons. So what they will do? It will lose electrons. So and forms chlorine gas. Okay, so this process is called oxidation or de-electronation. So here it is releasing electrons, that why it is called as de-electronation. This loss of electrons is called oxidation. So here Cl minus ion, it is going to the anode. After going to the anode, what it is doing? It is losing electrons. So as it is losing, chlorine gas is forming. So here at anode, chlorine gas is forming, liberating, and at cathode, sodium metal is depositing. So these are the chemical reactions taking place at anode and cathode. So this is about electrolysis of fused NaCl. Okay. So when you pass electricity onto the molten NaCl or fused NaCl, whatever the ions already present in the electrode, they will move towards the electrodes. That means cation goes to cathode, anion goes to the anode. Okay, here cations are Na plus ions, here anions are Cl minus ions. So this Na plus ions go to the cathode. So there it gains the electrons and forms sodium metal. Okay, sodium metal is deposited on the cathode. So here this process is called reduction or electronation. So that is gaining of electrons are called as reduction. As it is gaining electrons, it is called as electronation. Similarly, whatever the chloride ions present in the solution, they will move to the anode. After going to the anode, they will lose electrons. Why they are losing electrons? Negative means it is having electrons, it is rich of electrons. So it loses electrons and convert into chlorine gas. That means chlorine gas is liberated at anode. So what is this process is called? This process is called oxidation. It is losing of electrons is called as oxidation. As it losing electrons, this process is also called as de-electronation. Okay, these are the following reactions taking place during electrolysis. So first this NaCl, molten NaCl. So here we are seeing two molecules of NaCl. So 2Na plus Cl minus. So this is the cation, this is the anion. So this cation will go to cathode. So after going to the cathode, this is the reaction. So what it will do, it will take two. One Na plus will take one electron. So here 2Na plus na. So 2 electrons. So it is converting into sodium metal. So whatever the sodium metal is forming, that is deposited on the cathode. So this is the metal, sodium metal. So metal is deposited on the cathode. Okay, so this is the reaction taking place at cathode. Then come to the reaction at anode. So what is happening here? Cl minus ions present in the solution, they will move to the anode. So here we are taking 2 Cl minus. So 1 Cl minus ion release 1 electron. Here 2 Cl minus ions releases 2 electrons and convert into chlorine gas. Okay. So this is called as oxidation. So what is liberating at anode? At anode, chlorine gas is liberating. Okay. So at anode, chlorine gas is liberating. At cathode, sodium metal is depositing. So this is a net reaction of the cell. So 2Na plus. So how to write the net reaction? So always left side, right side you have to write left side ions plus right side ions. These are the reactants plus products. These are the reactants, these are the products. So here in cathode, what are the reactants? This Na plus. And what are the reactant at anode? Cl minus. So 2Na plus 2Cl minus. And what are the products with the in this reaction? 2Na. And what are the products in this reaction? Cl2. So that's why 2Na plus Cl2. So why we are not mentioning? So whatever the electrons lost by this sodium, so those electrons equal electrons now. So that's why we are not showing the electrons. Okay. So this is the net reaction of the cell. Actually this is the off reaction. The total combinedly we call the net reaction. This is oxidation of reaction. This is reduction of reaction. We are combining those off reactions and we are getting the total net reaction of the cell. So here sodium metal is deposited at the cathode. Chlorine gas is liberated at the anode. So this is about the electrolysis of fused or molten NaCl. Okay. So we will go to the summary. So in this period, what we have discussed, electrolysis of fused NaCl we have discussed. Let's come to the objective type questions. Okay. So what type of objective type questions you may expect from this topic? So first question, during the electrolysis of fused NaCl, the reaction at anode is. So during electrolysis of fused NaCl, the reaction at anode is. So when you do electrolysis of this fused NaCl, what is the reaction at anode is asking. So here some options are given. A, Cl minus are oxidized. B, Cl minus ions are reduced. C, Na plus ions are oxidized. D, Na minus ions are reduced. So we see the last option, Na minus. So when NaCl is dissociated, Na minus ions forms? No, so this is wrong. So Na plus ions will form. Is they oxidized? No. This is the wrong answer. Cl minus ions. Is they reduced? No. Cl minus ions are oxidized. Okay. So fused NaCl, if you do the electrolysis of fused NaCl, this is split as Na plus and Cl minus. This Na plus ions will go to the cathode and Cl minus ions will go to the anode. Cl minus will oxidize, Na plus ions will reduce. So what is the option? This option is correct. Cl minus ions are oxidized. So answer is A. If you are perfect in that topic, you can answer it. Okay, Cl minus ions are oxidized. Answer is A. The next question. Okay, so this is the second question. The electrolysis of fused NaCl produces at anode and cathode respectively. Okay, when you do the electrolysis of fused NaCl, what are the products formed at anode and cathode? They are asking. Option A, Na and Cl2. Option B, Cl2 and Na. Option C, Cl2 and H2. Option D, H2 and Cl2. So just now we studied, no? The electrolysis of fused NaCl At cathode, what is forming? Sodium metal is forming. At anode, what is forming? Chlorine gas is forming. So here, what are the options? Fused NaCl produces at anode and cathode. First anode given, next cathode given. So at anode, what will be formed? At anode, what will be formed? Chlorine gas. At cathode, what will be formed? Sodium metal. So answer is B, not A. Here I wrote here. So at anode, chlorine gas. Cathode, sodium metal. So answer is, if cathode and anode they will ask, you have to write this one. Sodium and chlorine gas. At anode and cathode they are asking chlorine gas and sodium metal are formed. Okay, so answer is B. So okay, here if you see the diagram, at anode chlorine gas, at cathode sodium metal. So here anode and cathode they are asking chlorine and sodium gas. Okay, answer is B, that is not A. Then next, come to the next. Through the fused sodium chloride, electric current can pass out due to the presence of. Through the fused sodium chloride, electric current can pass out due to the presence of. So here what we are doing, through the sodium chloride, we are passing electric current. So how they are passing? Due to the presence of what they are asking. So free electron, free ion, free molecule, the atoms of sodium and chlorine. So not free electron, so not free ion, the atoms of sodium and chlorine. So the electric current can pass out due to the presence of what? Free molecule. Okay, through the fused sodium chloride, the electric current can pass out due to the presence of this free molecule. Okay, not for free electron, not free ion, not atoms of sodium and chlorine. This is due to presence of the free molecule. Answer is C. Next, in an electrolytic cell, the electrode at which the electrons enter the solution is called dash. Okay, once again we'll read the question. In an electrolytic cell, the electrode at which the electrons enter into the solution is called dash. The chemical change that occurs at this electrode is called dash. Okay. Option A, anode oxidation. Option B, anode reduction. Option C, cathode oxidation. Option D, cathode reduction. So what is the answer? D. So always you remember, so like these options, always at anode oxidation, always at cathode reduction. So if you see the options here, so anode oxidation, cathode reduction. Cathode oxidation, anode reduction. These two options are wrong. Okay. At anode, reduction will not take place. Okay. At cathode, oxidation will not take place. Okay. So either may be A, either may be D. So in that, so here first here, you see here, in an electrolytic cell, the electrode at which electrons enter into the solution. What is the meaning of that? The electrons enter into the solution. It's called cathode. Okay. The chemical change that occur at this electrode is called reduction. So in electrolytic cell, the electron at which the electrons enter into the solution. So here what is happening? Electrons are releasing at the anode. So what they will do? They will come to the cathode. So that what is happening? Electrons are entering into the solution. At where? At the cathode. So at cathode what is happening? Which reaction is taking place? It is reduction, gaining of electron. So answer D is the correct. Okay, you have to read the question carefully and you have to. So actually this type of question you will expect in your entrance exam only, not in your theory question. So these objective type questions are useful in your is at entrance. So if you are perfect in the topic, then only you can give the answer to this type of objective type questions. So you have to read carefully. So here in an electrolyte, the electrolyte is the electrons enter the solution. So where from anode to cathode electrons are getting. So electrons are entering the solution. That is called cathode. So which chemical reaction taking place at this electrode? At this electrode only is asking. So which is, that is reduction. So answer is D. So this type of objective type questions you may expect from this topic. Next is questions. Explain, direct question you will get. Explain the electrolysis of fused NaCl. So that is for 5 marks. So what you have to do totally, you have to explain. So from starting onwards. So First, actually, what you have to do, you have to explain it clearly. So direct when electricity is passed through molten NaCl, you should not do like that. So already here I explained the electrolytic cell in the last class, no? What is the structure? So then an electrolytic cell, fused NaCl is taken. So you have to, two platinum rods are dipped in that NaCl solution. So these are called as electrodes, and these two rods are connected to the two poles of the battery through copper wires. So whichever the rod is connected to the positive pole is called as anode, and whichever rod is connected to the negative pole is called cathode. Then this one you have to write there. So I wrote this one, I didn't write there. Okay, then from here onwards it is there. Okay. So and you have to draw this diagram. There also diagram is there. No, you have to draw the diagram. Then when electricity is passed through molten NaCl, the ions already present in the electrolyte move towards electrodes. Then Na plus ions at cathode gains electrons from cathode to form Na. This process is called reduction or electronation. Similarly, Cl minus at anode loses electrons to form chlorine. This process is called oxidation or de-electronation. And these are the following reactions taking place during electrolysis. So first you have to write the dissociation, then you have to write the reaction at cathode. These reactions are very, very important. Separately, they can ask like that also. Write the reactions taking place at anode and cathode during the electrolysis of fused NaCl. Like that also they can ask. Okay. So if you do the electrolysis of fused NaCl, what are the reactions taking place at anode? That is for 3 marks question. So whatever the question, this is the direct question. Write the, explain the electrolysis of fused NaCl means that is 5 marks question. If you, they will ask only equations means that is for 3 marks question. These equations very, very important, and you should know how to write the oxidation reaction, how to write the reduction reaction. So oxidation means, reduction means it is taking electrons. So the electrons will be on the left side. Okay. So if it is oxidation, it is releasing. So electrons will be on the right side. It is giving off. So here chlorine gas, like this you have to write the equation and you have to draw this diagram, you have to label it. This is anode. Actually here inert electrode and the poles also not shown. So you have to see here. So for here we will share the screen, you share, I will share. So we will use the whiteboard. Okay, like this. So this is the electrolytic cell. That means this is the beaker containing electrolytic solution, that is fused NaCl or molten NaCl. So dip the 2 electrodes here. So it is connected to the 2 poles of the battery. One is connected to the positive pole, one is connected to the negative pole. So whichever is connected to the, so this is the negative pole. So this is the positive pole. So this is called as anode. This is called anode. This is called cathode. Okay. This is called cathode. This is the fused NaCl. Okay, fused NaCl. So there in diagram, inert electrode, and positive and negative pole not shown. This figure only shown. So here positive ions, negative ions will be present in the solution. Okay, positive ions and negative ions will present in the solution. Positive ions, negative ions. So this negative ion will move to the anode. Okay, this is positively charged electrode, and this positive ion will go to the cathode. So here sodium metal is deposited on the cathode. Here chlorine gas is liberated at the anode. Okay, so like this you have to draw the diagram. Okay, so the same this figure only here also given, but here actually chlorine gas shown, here sodium metal not shown. Here they wrote inner electron and electron flow from anode to cathode. So here electrons are releasing, at anode electrons are releasing. So electrons are flowing from anode to cathode. Okay, so like this we have to explain the electrolysis of fused NaCl. Okay, so if you have any doubts, you have to clarify these doubts and you have to write the equations. So while writing the equations is very important. So at anode Cl minus, what they will do, it will loses. While writing losing electrons after arrow you have to, so most of the students confuse here only. So they will keep electrons here. Oxidation means at anode Cl minus, it is having negative charge, so it will release electrons. So two chlorines we are considering, so it will release two electrons and forms chlorine gas Cl2. So this is chlorine gas, this is the symbol for above arrow. Plus it will release two electrons. So whatever the electrons released here, they will flow through this copper wire and go to the cathode. Okay, so like this electrons will flow. So what is happening at anode? Two sodium ions will take, one sodium ion will take one electron. Two sodium ions will take two electrons and they will convert into sodium metal. So okay, sodium metal is deposited at the cathode. So clearly you have to explain. So sodium metal is deposited at the cathode and chlorine gas is liberated at the anode. Okay. So with this we finished electrolysis of fused NaCl. So in the next class we'll study electrolysis of aqueous NaCl. There I will show what is the difference between electrolysis of fused NaCl and electrolysis of aqueous. So today we studied electrolysis of molten or fused NaCl. Okay. So in the next class we'll study the electrolysis of aqueous NaCl. If you have any doubts, you can clarify your doubts in the next class. We'll see. Okay. We'll finish the electrolysis of fused NaCl. So only one question I have given. Explain the electrolysis of fused NaCl. So already I told here this question for 5 marks and 3 marks also. How they will ask? Write the equations at anode and cathode during the electrolysis of fused NaCl, they will ask. So just you have to write the equations taking place at anode and cathode. Okay, so with this we finish electrolysis of fused NaCl. Okay, thank you students.